Hello everyone. We are the students of University of Oklahoma and we are going to give a presentation on our data mining project which is crop yield prediction. We are a team of 3 members, myself Divya Janakuti, my other team members are Prudvik Yalagadda and Kranti Kumar. This is the outline of our project that we are going to explain to you in detail. Coming to the introduction of the project. Agriculture is a significant subsistent of the world economy. To improve crop yields, farmers always need timely guidance to predict future crop productivity and perform analysis to help farmers maximize their crop production potential. Yield prediction is a significant problem in agriculture. The amount of data on world agriculture is enormous. For agricultural problems, data mining is widely applied because every farmer wants to know how much yield they can expect. According to FAO, there are currently 795 million people without access to sufficient food, and by 2050, the world will have 2 billion additional people to feed. To handle new issues with food security, particularly in the era of global climate change, crop yield prediction is essential. Accurate yield forecasts boost efforts to prevent famine by assisting farmers in making knowledgeable, economic, and managerial decisions. Data mining is a method of extracting, transforming, reading, and predicting meaningful facts from large pieces of information to extract some patterns and convert them into understandable structures for further use. The project aims to construct a farmer-friendly interface that enables crop yield analysis based on available datasets. Various data mining techniques can be used to maximize and predict crop productivity. By applying data mining techniques to historical climate and crop production data, multiple predictions can be made based on accumulated knowledge to improve crop productivity. In this project, there are 4 data sets related to rainfall, yield, temperature, and pesticides. These data sets are used to predict the yield of the crop. Various data preprocessing techniques are applied on the raw dataset. Regression models are performed on the dataset that is obtained after the preprocessing. There are 3 regression techniques, namely KNN, linear regression using gradient descent, decision tree that are being implemented to predict the yield of the crop. For every algorithm, the performance metrics are calculated to evaluate how well an algorithm is working for crop yield prediction. The algorithm with best performance metrics is used in the GUI. This GUI will predict the crop yield when a user gives input values for the features that are provided. Now, we see related work that has been performed in the field of crop yield prediction. In the first paper, the remote sensing community, crop production predictions have been made using many remote sensing data. The normalized difference vegetation index, the two-band enhanced vegetation index, and the normalized difference water index are some of the frequently used features in this particular paper. In the second paper, crop growth models have been presented to stimulate and forecast crop output under various conditions such as climate, genotype, soil characteristics, and management factors. To analyze and forecast genotype response in various contexts, a recurrent neural network-based model that used pedigree relatedness metrics and weekly meteorological parameters was used. The research topic was complicated by the time and money required to create a sizable dataset that accurately represented a broad range of genotypes and settings. In the third paper, Machine learning techniques such as artificial neural networks support vector regression, k nearest neighbors, and random forest were suggested for greater accuracy. In this paper, 745 instances were used. 70% of the data were randomly chosen for the training model, while remaining 30 were used for the testing model. Using this data set, the findings demonstrated that the random forest method achieved the maximum accuracy thanks to its error analysis results for all the different feature subsets.
Hello, myself, I am Kranti. I would be talking about what datasets we have considered for this project. The datasets that we have taken are from Kaggle. So it is called as crop yield prediction dataset. It consists of 4 datasets, which are the yield dataset, pesticides dataset, temperature dataset, and rainfall dataset. The data in these 4 CSVs have been sufficient to predict our models. The yield dataset consists of all the data related to the yield, such as domain, area, item, year, unit, and value. The pesticides dataset has the data such as area, item, year, unit, and value. The temperature dataset has the following features: year, area, and the average temperature in Celsius. The rainfall dataset has an area, year, and average rainfall as the attributes. Nothing in this dataset is being changed. Understanding the dataset. So in this, the yield dataset has 56,717 records and 12 attributes, out of which area, item, year, and value attributes are retained by dropping the other features. The pesticides dataset has 4350 records and 7 attributes, out of which area, year, and value are retained. The temperature dataset has 71311 records and 3 attributes, and all 3 attributes like the year, area, and average temperature are retained. The rainfall dataset has 6727 records and 3 attributes, and all the 3 attributes are retained, that is area, year, and average rainfall. Most of the attributes are of numeric data type. There are 2 categorical data types, that is area and item, where we have denoted the area as country and the item as type of crop in our data conversion. So this is the final data set that we have obtained by converting all the column names and all. So after merging the data set, we have total of 25 attributes, and from that we have retained 7 attributes. So area is one of them, year, pesticides, average rainfall, temperature, and item, nothing but type of crop, and HGHA yield. So basically we are representing yield in the form of HGHA. So in this we are having 2 categorical and 5 numerical values.
Hi, I'm Prithvi Yarlakadda. So I will be speaking about the pre-processing that has been performed on our dataset. Data pre-processing is an essential step in the data analysis process is data preparation. Many organizations or businesses are interested in finding ways to turn the data into cleaned form that may be used for highly profitable reasons. Even if there is low quality data available in very of the data sources on the internet, pre-processing raw data is necessary to create high quality data for many computer science applications, including pattern recognition, information retrieval, and machine learning. Data preparation and cleaning typically account for 80% of overall effort put into data engineering in practice. Data collection, data integration, the transformation of data, data cleaning, and data reduction are the key data preparation techniques. Data preparation techniques are focused on evaluating raw data to produce quality data. So in this project, the data is being read from all the 4 data files, which are yield, pesticides, temperature, and rainfall. Within these 4 datasets, there are some redundant attributes. For example, in the yield dataset, attributes such as domain, domain code, year code, and element are removed to avoid redundancy. 70% of the data is being dropped in the yield dataset. In the temperature dataset, no attributes are being deleted. And in pesticides and rainfall datasets, we are not deleting any attributes. Upon the removal of redundant attributes, the attribute year is used to group and combine all the other attributes. This merged data is considered as the final dataset. This final dataset is again cleaned by removing the null values, deleting the unwanted and rejected columns, and removing duplicate values. The final dataset consists of all the attributes such as area, item, year, yield, average rainfall, and usage of pesticides in tons, and average temperature. On the final dataset, null validation testing is performed. Since the average rainfall in the rainfall dataset has null values, the missing values are imputed with the mean value of rainfall data. The percentage of missing values in rainfall is 0.0004%. After the missing value imputation, the outliers in the dataset are removed based on box plots. Then the interquartile range is calculated, and the data points outside the interquartile range are removed. The cleaned data is split into labels and features. The features are again then stored into a pickle file. After the splitting of features, feature encoding is being performed on area attribute to convert the categorical data into binary data, which comprises of zeros and ones. It is 0 if crop is not present in that particular area, and 1 if crop is present in that particular area.
Now, we will be discussing the algorithms that were used for crop yield prediction. The first technique that we used is KNN regressor. A data mining method known as k-nearest neighbor method is regarded as one of the top 5 methods. The value an observation has for a particular characteristic is taken to be its coordinate in that dimension, resulting in a set of points in space. This is done by treating each feature in the training set as a separate dimension in some space. The distance between 2 points in this space can be determined by some appropriate metrics by comparing how similar 2 points are to one another. The method selects the k closest data points to the new observation and selects the most frequent class among them to determine which of the points from the training set are similar enough to be considered when selecting the class to forecast for a new observation. It is known as the k-nearest neighbors algorithm. In the distance function, there are other ways that can also be used, such as Minkowski distance, Jaccard index, and Hamming distance. The advantages of KNN are it is very easy and simple to implement, and it can perform well with enough representative data. It is also ideal for non-linear data since there is no assumption about underlying data, and it can be used for both classification and regression. The disadvantages are it requires high memory storage, and the determination of the value of k is difficult. Production is slow if the value of k is high. The values of the closest known neighbors can be used to predict crop yield. Calculating the Euclidean distance between those places makes this achievable. Thus, for the specified input features, crop yield may be predicted. Different distance functions, including the Euclidean distance function, can be used to calculate the separation between 2 points in a feature space. Assuming that P and Q are shown as a feature vectors, Euclidean distance can be used to calculate the distance between 2 points. After we have performed the KNN model, we received these particular observations as our performance metrics. We have calculated the R2 score, mean absolute error, mean squared error, RMSE, NRMSE, confidence interval, and the execution time of the model as follows.
The next algorithm that we have performed is linear regression using gradient descent algorithm. Linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable that we want to predict is dependent variable, and the variable that we are using to predict the other variable's value is called the independent variable. The main goal of simple linear regression is to consider the given data points and give a best fit to the model in a best way possible. To obtain this, we will be using a cost function. So a cost function provides the best possible values for slope and intercept to make the best fit for the given data points. We do this by converting it into a minimization problem to get the best values for slope and intercept. The error is minimized in this between the actual value and the predicted value. We do this minimization until we get the mean squared error value as minimum. The next important part of linear regression is gradient descent. It is a method of updating both slope and intercept values to reduce the mean squared error. So the idea behind this is to keep iterating between slope and intercept until you get the mean squared error value to a minimum. For the gradient descent, if we consider more number of iterations, a more number of data points will be considered and we might get a higher accuracy rather than taking small number of iterations. Coming to the advantages of linear model, it is easier to implement, interpret, and efficient to train. Also, it performs exceptionally well for linearly separable data. Also, it handles overfitting very good when using reduction techniques, regularization, and cross-validation dimensionality. Also, it has some disadvantages, such as the assumption of linearity between dependent and independent variables. It is also quite often prone to noise and overfitting. It is also sensitive to outliers. These are the performance metrics that we have achieved by performing linear regression on our dataset. Now, decision tree algorithm. A decision tree is a tree data structure that consists of an arbitrary number of nodes and branches at each node. A node with outgoing edges is called an internal node. Other nodes are called leaves. The instance that is used for regression or classification is splitting into two or more groups by an internal node concerning a specific function. A decision tree usually employs a greedy strategy in that it makes the best optimal choice at each stage, which overall leads to the best solution. A decision tree makes decisions by splitting nodes into subnodes. This process is performed multiple times during the training process only until a homogeneous nodes are left. And this is the only reason why a decision tree can perform so well. In decision tree splitting, we can perform splitting using 4 different ways, which are a reduction in variance, calculating the Gini impurity value, information gain value, and a chi-square value. In our project, we will be using reduction in variance. Decision tree splitting is performed based on reduction in the variance as the target variable is continuous. It is so called because it uses variance as a measure for deciding the feature on which node is split into child nodes. Variance is computed by the following formula, which you can see on the slide. Now, coming to the advantages of decision tree regression. It can be used for both classification and regression problems. It can also capture nonlinear relationships, also very fast when compared to KNN. The data preparation is very less compared to other algorithms. Also, decision tree has few other disadvantages, which are during the decision tree split for numerical variables if millions of records are present. Decision tree for many features takes time. Also, the growing with the tree from the training set. These are the performance metrics that we have obtained by performing decision tree regression on our dataset. For the final model selection, we are choosing k nearest neighbors as our final model because we have obtained r squared value higher. R squared is a statistical measure that represents the proportion of the variance for a dependent variable that is explained by an independent variable or variables that are present in a regression model. Apart from the R2 score, we have also performed some other metrics and also we have calculated confidence intervals by using t-test and to determine if the models are significant or not. Now, coming to the conclusion of this project, the crop yield description can provide an in-depth analysis of crop productivity and its yield. It is an important tool to identify areas where crops are performing well and the areas that need improvement. This can be used to inform decisions about how to improve the crop productivity in future. Moreover, the crop yield description can be used to compare different varieties of crops and their performance in different areas. A crop yield description is an important tool for evaluating and monitoring crop productivity. It can help farmers and other stakeholders make better decisions about how to manage and improve crop productivity. Also, a future work can also be performed on this crop yield description. In the future, research should focus on developing more efficient and accurate methods of crop yield description. This could also include developing automated systems to collect and analyze more data more effectively. Also, various features such as soil type, water availability, climatic conditions, and the nature of plant can also be considered to predict the yield of crop. Everyone will be able to use real-time weather and soil statistics that can be collected manually using the equipment or downloaded from the reliable sources.
Coming to web application, for the front-end implementation, the scripting languages that have been used are HTML, CSS, JavaScript. All the implementation is carried out using Microsoft VS Code as our main terminal. These are the resources that we are using for our project. For the front end, we are using HTML, CSS, Bootstrap, and JavaScript. We are using Python as our main programming language, and there are certain necessary packages which we have to install for our project to run. So they are NumPy, Pandas, scikit-learn, SciPy, and Pickle. As I mentioned, we are using Visual Studio Code as our main code editor, and we are using Flask as our main framework for integrating front end and back end. After the environment and packages are set up, we will be writing our code in Python, and the UI is built. This process will be shared in the later part of the video. Upon the deployment of UI, a greeting page will be displayed to the user. The greeting page gives us a short information on how to use this application. Is displayed on YouTube video by showing a YouTube video on how climate change will impact the yield. Once the pop-up is closed, user can view Once the pop-up window is closed, user will be redirected to the home page. In home page, user will have three choices. One is home, the second is yield recommender, and the third one is about. When user clicks on the home button, user will be redirected to the home page. When the user clicks on the about page, user will be redirected to the about page, and user will have a short inception on crop yield prediction. If the user clicks on the yield recommender option, user will be redirected to a prediction page where the end user can input some parameters to predict the yield of the crop confined to a particular country. To make a prediction of the yield, user needs to tap on yield recommender button. The yield recommender page looks as shown in the presentation. In the yield recommender page, the user will have five options to predict based on the functionalities. The first one is the country name. Here in this field, the user needs to select the specific country where he or she wants to choose the yield prediction. And the second option is rainfall. In this option, the user needs to enter the estimated average rainfall in millimeters of that area manually. The third option is temperature. In this option, the user needs to enter the estimated temperature in Celsius of the area manually. In the fourth option is pesticides usage. Here in this option, the user needs to enter the pesticides usage value that they use in that area manually. And the fifth option is basically dependent on the country name. So whenever a country name is selected, based on that particular country name, he will have a set of crops which the user needs to select. After entering all the required numerical values and selecting all the options, then the user will be provided with the predict yield option through which he can get the yield prediction. Once when the user taps on the predict yield button, user will be redirected to the prediction page where user will be displayed with yield prediction value, R2 score of the model, confidence interval of the model. Now the project implementation and UI implementation will be shown. Code. Now let's understand how the backend links to the front end and how the workflow goes. When the user clicks on the predict yield button, the options selected from the drop down and the data manually entered by the user is collected and stored into a list. Then the user entered data list is appended to the original data. This data is again pre-processed and then a final clean data is obtained. The clean data is then converted into numerical data from the categorical fields using a function called pandas.getDummies from the pandas package, and function called log is also used to capture all the columns and then store them as features. All the features are trained using the selected model. Here, since we got the KNN regressor as our best model from the metrics, we are using KNN models pickle file as our trained dataset model. That the user entered is passed to the algorithm and a resultant predicted value is obtained along with the R2 score of the model and confidence interval. So see how the deployment of app.py works. So let's run the app.py application. So once the deployment is completed, we will be provided with a link. So let's copy the link to access the front end window. User will be provided with instructions which user needs to follow, and before accessing the application, user needs to study this user manual. Pop-up window is closed. User will be having 3 features in which user needs to redirect to the yield recommender page. So is redirected to the yield recommender page. He will have 5 features. Here when user particular country, he will be having crops of that particular country. So whenever a user selects different country, there will be different types of crops confined to that particular country. So let's select this type of crop, and when we try to predict without selecting the other 3 features, it will show a warning to need to be filled. So these 3 fields need to be also filled in order to predict yield. So these three fields, user need to enter the numerical values. So let's enter a value. Here rainfall should be entered in millimeters. For the temperature field, let's select a value. So in this temperature should be entered in Celsius. Let's enter pesticides. So after entering all the fields, let's try to predict. So here whenever a user enters a value out of range, he will be having a warning again to enter that particular value in certain range. So let's decrease the value. So when user clicks on the yield button satisfying all the requirements, then he will be redirecting to the prediction page where he will be displayed with yield prediction of that particular country, R2 score of the KNN model. We have selected the KNN model as our best model based on the confidence interval. So here is the confidence interval of KNN model. I'd like to conclude by saying that farmers will have a great advantage by using our application. They will have an estimate on what type of crops to produce of that particular country.